All right, trig students, what we're going to be doing is wrapping up chapter 6. What we're going to be basically doing in this section is solving equations with a inverse trig function already in play, or we'll bring it into play. So recall what we know with regards to our inverse trig functions is they do have a restricted domain because we need to be one-to-one. And that plays a role at some points and to determining exact values, where we're going, what quadrant we're in, what are we rotating, positively or negatively, all that good stuff. I know we're getting a little tired. So I know when you guys look at this first round of example problems that we do for inverse trig functions, they're going to have an interval, and that's because of the restriction. I'm just worried about the algebra of getting to the position that we are in. So essentially in this first round of problems, all we're doing right now, I have y in terms of x. So what we want to do is just write x in terms of y in all these cases. And of course, to undo that sine, to undo that cosine, tangent, and cosecant and all that, what we're doing is invoking the inverse cosecant, the inverse sine, the inverse cosine, inverse tangent at some point, which draws into those restrictions. So that's why when you guys are looking at your homework on My Math Lab, you'll see the interval that we're considering. I'm just going to worry about you doing the algebra because that's actually what's more important here at some point. So solving for x, we got to get this sine by itself. So algebraically, we got to handle this 3 first. So I'll divide both sides by 3, and let me rewrite this. This is the sine of x over 3 equals y over 3 at this point. And of course, to get to that x, what we'll do is we'll rewrite this as the sine inverse of y over 3. And then to get x by itself, I'll multiply both sides by 3. And in this case, we get that x equals 3, the sine inverse of y over 3. All right, so there's basically all we're being tasked to do is to rewrite in terms of the other variable. So we're invoking an inverse sine. And because of that, again, we're restricted. But I'm not going to worry about the restriction. Let's just worry about the math and getting there. Again, for this next one, we got to get to this x. So I'll begin this journey by, how about we divide everything by -1. That basically gets us cosine of x over 2 is equal to -y. Invoking my inverse cosine, we do our conversion. All right, that's really what it's all about. It's about converting. And then solving for x, I'll multiply both sides by 2. And in this case, we get x equals 2, the inverse cosine of -y. And again, there are some restrictions, but I'm just concentrating on the algebra. So pretty much some basic algebra ideas. Trying to get a little harder. We're not separate. We don't have a multiplication. We have an addition. So to reverse that addition, I'll subtract. And so we'll get the tangent of x minus 2 is equal to y minus 4. Invoking my inverse tangent function, we get that x minus 2 is the inverse tangent of y minus 4. Adding 2 to both sides, in this case, we get that x is equal to the inverse tangent of y minus 4, and then plus 2. All right, so there's the algebra of converting x in terms of y, just using algebra. All right, and at some point, once we isolate the trig function, we convert it right to its inverse situation, and we can kind of clear up. We're trying to get to the angle, right? I call it an argument. So we just keep doing that. And then the same thing here, right? We're adding a negative square root of 2. So I'll begin this journey by adding the square root of 2 to both sides. This becomes 3 cosecant of 2x minus 1 equals y plus the square root of 2. Handling that 3, I'll divide both sides by 3. And so we get cosecant of 2x minus 1 is y plus the square root of 2 all over 3. To reverse this cosecant, we'll introduce the inverse cosecant. All right, and then to solve for x, I'll add 1. So we get 2x equals the inverse cosecant of y plus the square root of 2 over 3 plus 1. And then, we can basically multiply both sides by a half. And so we get x equals 1/2 cosecant inverse of y plus the square root of 2 over 3, right, plus 1/2. All right, and so we basically solve for that. There are restrictions again because of the inverse cosecant that we did, the inverse tangent, the inverse sine, the inverse cosine. But again, just trying to keep things simple. We know it's there, but we're just gonna just use our algebra skills. So hopefully that's a good review of some things we did earlier in chapter 6. All right, but all we're doing is basically flip-flopping. We started solve for y, and we're converting it to solve for x. All right, so we're basically trying to find our input, right? So there's our output of all this. So how do I convert this so it's we reverse it? Our input becomes the output and all that other good stuff. All right, so just a bunch of algebra. Follow suit. There's I think several problems in the homework that are similar to it, and it's just doing some algebra and then invoking an inverse trig function, and then just doing some algebra to finish it off. To get again, the idea is to get x by itself. We start with y by itself. We need to get x by itself. All right, so let me cut to a new video where we start doing some exact values and using our unit circle essentially, and our restrictions. But I'll get to that a little later.